Okay. Listen, children. Even and odd numbers, pages 39. A number which is exactly divisible by 2 is an even number. Multiples are up to are even numbers. So a number which is exactly divisible by 2 is an even number. Underline this statement for the blank. 0, 2, 4, 6, and 8 are even numbers. The divisibility test proves that any number ending with 0, 2, 4, 6 or 8 is an even number. ये आपको मैंने कल भी समझाया था. Then a number which is not divisible by 2 is an odd number. Obviously, the number which is not divisible by 2, you will say it is an odd number, and these are alternate numbers. Any number ending with 1, 3, 5, 7, and 9 is an odd number. Now, after even and odd numbers, we did in class the definition of prime numbers. I have told you before that a natural number that has only two distinct factors, namely 1 and the number itself, is a prime number. This is also the definition for prime numbers. Note it down for the blank. A number which has got only two divisors, two factors, they are divisible by 1 and itself are called prime numbers. So after prime numbers, you know that the smallest natural number is 1. And 1 is not a prime number because 1 is equal to 1 into 1. Its two factors, its two factors are 1. 1 and the number itself are the same. So the divisor of 1 is 1 and the quotient of 1 is 1. So therefore, we cannot say that 1 is a prime number. 1 is excluded from the prime numbers. So factors of other numbers like 2 has got only two factors, 1 and 2. 3 has got only two factors, 1 and 3. This is the explanation given for the prime and composite numbers. When you have got more than two divisors, 3 or more than 3 divisors of a number, that number is a composite number, not a prime number. Like 4, see, 4 is divisible by 1, divisible by 2, and divisible by 4 itself. So it has got 3 divisors. It means 4 has got 3 divisor. It is not a prime number. So we will say that 4 is a composite number. 1 is not a prime number. See? 2 is the smallest even prime, and then 4 is the smallest composite number. Composite numbers are the numbers which has got more than 3 or more than 3 divisors. Page is 40 now. Composite number, a number which has more than two factors is a composite number. More than two factors mean it has got 3 or more than 3 divisors. You will say factors mean divisors. So you will say that the number is a composite number having 3 or more than 3 divisors. So these are the definitions for composite, prime, and even and odd numbers. Write down these definitions for the blanks. Now, there is a Siva of Eratosthenes, a mathematician. So you have to write down like me, the whole counting in your rough notebook first. Do it in the rough first. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Up to 100, children, write down in your notebooks. So 1 is neither prime nor composite process. Then 11, 12, 13, 14. Do like this. and 30. 1, 2, 33, 34, 35, 36, 7, 8, 9, and 40. 41, 43, 44, 45, 46, 47, 8, and 50. 51, 52, 53, 9, and 60. 61, 62, 63. Be with me, class. 64, 65, 67. Write down the counting with you. We will sort out the even and odd numbers from 2 to 100. So what is the procedure? I'll tell you. Write down this counting upon your notebook like I am doing. 70, 70, 67, 66 is missing. Okay. 76, 77, 78, 79, and 80, 81, 82, 83, 84, 87, 8, 90, 91, 92, 100. So up to 100, write down the counting like I have done on the notebook. So we will sort out the table of 2 from this counting. We will cross the table of 2. 2 is there, circle 2 as it is a prime number having only 2 divisors. It is divisible by 1 and 2. So circle 2 and cross the table of 2 from the whole counting. All even numbers 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 58, and 60, 62, 64, 66, 68, and 70. A number which has got an even number in the units place or 0 in the unit place is said to be an even number or divisor of 2, multiple of 2. So you cross out all the even numbers from the like table of 2 from the counting from 2 to 100. Now the next number is 3, which is also a prime number having 2 divisors. It is divisible by 1 and 3. So cross out the table of 3 from the counting. 9, 15. Sum of digits is a multiple of 3. The number is divisible by 3. So 21, 2 plus 1 is 3. Then 27, 7, 8, 9. 9 is a multiple of 3. Then 33, divisible by 3. 3 11s are 33. 39, a multiple of 3. 45, a multiple of 3. Then 51, a multiple of 3. 5 plus 1 is 6. 6 is divisible by 3. 12, 57, 7 plus 5, 5 plus 7 is 12, divisible by 3. So cross this number. 6 plus 3 is 9, 63. 63 is a multiple of 3. Then 66, already we crossed it because it was in the table of 2 also. 69, also divisible by 3, cross it. Then 75. 7 plus 5 is 12. So 75 is divisible by 3. Therefore, cross it. Then 81. 8 plus 1 is 9. 9 is a multiple of 3. Then 87. Then 93 and 99. These all multiples of 3. So we cross the table of 3 from the given numbers from 2 to 100. Then comes 5, the next prime number, having only 2 divisors, divisible by 1 and 5. So cross a table of 5 when there is 0 or 5 in the units place of a number, the number is divisible by 5. So all the numbers having 5 in the unit space cross these numbers, you will cross the whole table of 5. And the numbers which has got 0 in the unit space, we already crossed those numbers with in the table of 2. So all the numbers having 5 in the unit space, you cross from the counting. So now you are left with 7 as a prime number, divisible by 1 and itself. Now cross the table of 7 from this counting. 2s are 14, 21 crossed. Look somewhere, you will find out the multiple of 7, 49, and then 77, okay. The table is given in the book also. After cutting the table of 7, you will see that you are left with 11, 17, 19. These are, circle these numbers, these are the prime numbers. 29 then, 23, 29, then 31, 37, 41, 47, 53, 59, 61, 67, 71, 73, 79, 79. After 79, you have 83. And in the counting, 89, 97. 91 is divisible by 7. Okay, these circled numbers are prime numbers. All circled numbers are prime numbers. So from this table, you can see we did the sieve of Eratosthenes. It tells us about the prime numbers which are divisible by 1 in itself has got two divisors only, two factors only. So we excluded 1 from the list as it is not a prime number. So 1 exclude 1, it is not a prime number. So now we crossed all the tables of 2, 3, 5, and 7 from the counting. So we get all the prime numbers. Now, what are twin primes? See, in the table, 3 and 5 are twin primes, 5 and 7 are twin primes. Why we say 17 and 19 are twin primes? Because when we say that 3 and 5 are said to be twin primes, it means when we subtract 5 and 3, do the subtraction of 5 and 3, we get 2. When you get 2 in the answer, when you subtract two prime numbers, consecutive prime numbers, having the difference of 2, they are known as twin primes. So there are so many twin primes, 5, 7, 17, and 19. Here, 59 and 61, then 71 and 73. These all are twin primes, said to be twin primes. So written in the book 3, 5, 5, 7, 11, 13, 17, 19, 41, 43, yes, 41, 43. In the table 71, 73. These are, and so on, because we did the counting up to 100. So there's no end to counting, but up to 100, these are the twin primes given in the table of numbers. Then prime, there is only one prime triplet having difference of 2, which is 3, 5, and 7, having difference of 2 in between. So 3, you can say 3, 5, and 7 is the only prime triplet. Prime triplet. So you did the sieve of Eratosthenes, page 41, to find out the prime and composite number, prime and composite numbers, and twin primes and prime triplet. Tomorrow, inshallah, we will start doing the exercise 3B. Write down the definitions and do this sieve upon your notebook. Write down the twin primes and prime triplets on your notebooks. So then I'll check your notebooks, inshallah, tomorrow.